This is ContactTalkRadio.com. Consciousness in action. And you are taking action into your consciousness by tuning into Contact Talk Radio.
And on TuneIn.com, Ping.fm, and Upsnap Mobile.
Contact Talk Radio.
That Naturopathic Podcast. TNP.
Hello there. Hi, and thanks for joining us. I'm Dr. Cara Denisio.
And I'm Dr. David Miller, and we hear your frustrations. This show is for you.
This show is for you if you're feeling like your current healthcare strategy is not getting to the root cause or the underlying reasons for your health.
This show is for you if you've been told that you're fine, but you definitely don't feel very well.
This show is for you if you're walking out of your doctor's office with 1, 2, 3, 4, or even 5 medications without any mention of diet, lifestyle, or a long-term game plan.
This show is for you if you've got several specialists taking care of you, but no one is really putting it all together.
This show is for you if you believe that health should be part of healthcare. These problems have solutions.
We know it.
Our patients know it.
And we want you to know it.
Naturopathic medicine is the solution that you need to know about. All right, here we are with That Naturopathic Podcast. Hey everybody, it's Dr. Cara.
And it's Dr. Dave.
And today we have, hey, it rhymes, Dr. Bryan Rade is joining us today, a fellow classmate of ours. And you are coming to us from Halifax today, right?
That's right.
Yeah, well, welcome. Dr. Rade, we're really excited to chat to him today. He puts out some really awesome content and is a pretty smart cookie. I really like how your brain works. And we're looking forward to diving into something today about something you might not know off the top of your head, but we're hoping Bryan can let you know why this matters. And it's mitochondrial dysfunction. So
yeah, that's a nerdy term. That's a nerdy term, but that's okay. We got like a sort of nerdy crew here that will try and make it sound a little bit easier to the ear, right?
Let's do it.
Okay. I'm excited too, Cara. Dr. Rade's one of the naturopaths that I like to listen to. We little internet issue there. I'm just saying I'm excited to listen to Dr. Rade because he's one of the naturopaths that I like to listen to, the way he goes through problems too. So yeah, I'm selfishly pumped, and I hope you guys have a great time listening to his wisdom.
Yeah, and you teach naturopathic students, so we're excited to learn some lessons for you about mitochondria. So can you just tell our listeners a little bit about what mitochondria are?
Sure. So mitochondria are these little units in our cells. And when you might think back to biology class, I know those of us chatting here today probably learned about cell biology more times than we care to remember over the years between high school and undergrad and naturopathic school. But for the most part, when you see a cell depicted in a textbook, it shows maybe 1 or 2 or 3 mitochondria in the cell, and then all the other organelles like the nucleus and different things like that. But in reality, there's hundreds or thousands of mitochondria per cell. And actually in certain regions of the brain, there are literally 2 million mitochondria per neuron. In the cardiomyocytes, which make up i.e. the heart muscle cells, there's actually 30% of the cell volume is mitochondria. So just really to how important these little units are to make energy. So that's really their main job, but by essentially by proxy, they influence a number of other elements of cellular health. They have a big hand to play in antioxidant and pro-oxidant balance, like redox balance as it's called. They have a big impact on gene expression, and they talk back and forth with the nuclei of the cell, like the DNA in the nucleus of the cell. So they're very, very important structures, and I'm very excited.
Yeah, in grade 10, we call them like the powerhouses.
Mm-hmm.
Yeah, and related to that, maybe could you tell us why there's more mitochondria in certain types of cells compared to others, just to make like a comparison? Sometimes that can be helpful.
So where their main job is to make energy, then the tissues in the body that need the most energy are going to have more mitochondria by default. So brain and heart, they're pretty much working, well, they are working all the time. The heart's pretty much constantly working, at least at a baseline level, and then harder during exercise. And then the brain, of course, never truly turns off. It can go into a little bit of a, sleep mode, if you will, when it sleeps, much like a computer. But it's still working, of course, all the time. So it just speaks to the importance of that ongoing energy production. Also, just kind of I think, fun fact, and nerdy really is a good theme for this podcast, because by golly, like anyone who's excited about mitochondria, both talking about it and listening to somebody talk about it, be pretty nerdy. But just a fun nerdy fact. By some estimates, and it's really hard to calculate this, like we're made up of about 1 trillion cells. Some people say 100 trillion cells, like in any event, it's a lot of cells. And by some estimates, though, we make either our body weight in ATP, which is cellular energy, every day, or other estimates would say maybe half of it. So if I'm about 180 pounds, give or take, I'm making anywhere between 90 to 180 pounds of this cellular energy every day, which just,
that's
again,
crazy.
How much work these, you can call them the powerhouses of the cell. They're like the workhorses of the cell. These mitochondria are tireless and keep us going. Although when they start getting tired, then we might follow suit, unfortunately.
And ATP is like their energy currency. I don't know, Dave, you're good at analogies. You don't have a war analogy or something like that to pull in here?
He's good at them too. I've listened to him. He's good at them too. So we'll sort of let him go. But yeah, it's like an energy currency. And so they're like the Federal Reserve or Bank of Canada. They make all these energy currency molecules, and then the cells sort of spend them. Does that help?
I like it.
It helps me. Yeah.
Okay.
It's not as gruesome. I like your gruesome analogies better.
I know.
Okay.
I'm off my game, Kara.
So where do we go from here? So that's like the nuts and bolts, basically, of what the mitochondria are. What's the next level out from that? Once we look at the cell with the mitochondria in it and it's making ATP, how do you look at it next, coming out from there?
Well, basically the way you look at it, the way I look at it at least, is that from there it's asking the question, well, which systems in the body need ATP? Like which systems in the body need energy? And the answer is every single one. Every single part of the body needs energy to run. Just as, for better or for worse, money makes the world go around, energy makes human physiology go around. And so if you're asking yourself are mitochondria important for detox function? Yes. Immune system function? Yes. Energy levels? Yes. Neurological function? Yes. Respiratory function? Yes. Just name a system. Everything needs energy in the body. And what's really interesting to me, where I've lectured about this, I'm putting together actually a training course for physicians all about mitochondrial dysfunction, how to treat it. I've put about 60 to 70 hours of research time into this so far. And what's really fascinating to me is that you can't name a chronic or degenerative condition that isn't characterized by mitochondrial dysfunction when you look at what's happening on a cellular level. So whether it's cardiovascular disease, whether it's diabetes, whether it's autoimmune disease, whether it's Parkinson's, Alzheimer's, you just can't, chronic fatigue syndrome, fibromyalgia, you just can't name a condition where there isn't a component of mitochondrial dysfunction. And it makes sense because when we're diseased, we ultimately are not functioning optimally. And if we don't have adequate energy being produced in those crucial tissues, then of course that's going to be a contributing factor.
Mm-hmm.
So what are some of the determinants, Bryan, of how well a mitochondria is going to work? So are there some physiological conditions in which they would be less efficient or they wouldn't work as well? I'm thinking of something like oxygen or blood flow or something like that. Is there some conditions in which mitochondria prefer to they'll flourish in, and in some conditions do they not do so well?
Yeah, definitely. The way that I think about this and the way I explain it to my patients is that your mitochondria are going to work incredibly well if they have all of the nutrients that they need, all the ingredients they need to function properly, and if they are not burdened down or bogged down by the various things that interfere with the way that they work. So if a person didn't have, say, as you indicated, adequate blood flow to their tissues, then their mitochondria are going to have a hard time, because if the nutrients aren't getting into the cells, then the cell's not not going to work properly. Or if a person has some type of a condition where they didn't detoxify optimally, so say if a person was constipated and they hadn't yet seen a gut gangsta to get them figured out or fixed, then they're going to have more of a backlog of those toxins into their tissues, into their cells, and then those very toxins are what have a negative impact on the mitochondria. What's further really fascinating to me about the mitochondria, as I continue to geek out or nerd out, whatever the right nomenclature is here, the really interesting thing to me is that when you look at the impact of what the most potent toxins on the planet do in a human cell. So a great example would be heavy metals like mercury or lead. Like mercury is arguably one of the most naturally occurring toxic substances on the planet. Well, what does it do? Well, it gets into the mitochondria. It binds to iron and sulfur residues. It has a deleterious impact on antioxidant production, on the enzymes that produce antioxidants. In and of itself, it creates more free radicals. And so it basically just creates this incredible cyclone of oxidative damage in the mitochondria while interfering with the way the mitochondria work in the first place. So the poor cell can't make enough energy to actually kick the heavy metal out. And so you wind up with this just destructive wave going through. But so again, it's like, well, mercury is really toxic. Pretty much everybody knows that. But why? Well, it damages the mitochondria. And the same is true for other toxins, different chemicals, toxic effects of certain pharmaceutical drugs, toxic effects from mold toxins if people are suffering from mold illness. So as I keep saying to my patients and to my residents and to the students that I've been teaching at CCNM, our alma mater, the Canadian College of Naturopathic Medicine, it's all about the mitochondria. And I think it's true. Lots of confirmation bias coming my way. The more I learn about them, the more it really seems to be all about those mitochondria.
Well, it's kind of like if you attack the Federal Reserve, right? Or I don't know what it is in Canada, but if you attack the Canadian Mint, is that our equivalent? I don't know. Think of the social consequences of money runs the world, right? And just ATP and mitochondria, if you don't have that, you're up shit's creek, basically. Just when you were talking about that list, what about, I'm just reminded of our episode with Dr. Ben Snyder, and he talked a lot about water exchange through cells and minerals. And I'm just wondering how that would fit in.
Well, one of the interesting things with mitochondria is that if the mitochondria aren't working optimally, then there's going to be more oxidative damage. So where oxidative damage would kind of be the opposite of what antioxidants would do, where most of us know that antioxidants help to protect the tissues in our body. They're very protective for our cells, whereas pro-oxidants are very damaging for those cells. And so if the mitochondria aren't working optimally, then they actually start to leak pro-oxidants inside of their inner structure. So it's kind of like a nuclear reactor, where if everything's not just right and it starts leaking radioactive goo, it's going to start kind of poisoning the factory or damaging the factory, so to speak. And so if that starts to happen, if there's this if the mitochondria aren't working optimally, there's going to be more pro-oxidation, and the pro-oxidation is bad for lots of things. It can damage DNA, it can damage important cellular structures, but one of the things that it's going to damage is it's going to damage the lipids that make up our cell membranes. So every cell in the body is surrounded by this membrane of lipids, so like fat molecules with other stuff in there, but it's very, very fatty by percentage-wise, it's very fatty. And if those fats get damaged or oxidized, if you will, it's kind of like if you leave an old bottle of olive oil out for too long. When it's fresh, it's good. When it's not fresh, it's not only gross and kind of stinky, but it's also not very good for you. Mm-hmm. And so if that cell membrane gets oxidized, well, then that protective barrier that surrounds the cell, it's not going to work properly. All the wonderful transport proteins and receptors and things like that are very much dependent on the optimal function or optimal integrity of the structure of the cell membrane are not going to work properly. And so that's probably going to have a big impact on the transport of whether it's water or nutrients and things like that getting in and out of the cell. So there's a huge correlation there between mitochondrial health and the health of our cell membranes and all that transport that comes with that.
Cool.
Bryan, can you talk about I just want to go back to the mercury for a second. Is the reason that, you know that saying mad as a hatter and how mercury is quite neurotoxic, is that because of the energy demand of neurons, or I don't know this. I'm honestly just asking. I don't know if
Sure.
you know the answer.
Well, I mean, to my understanding, like mercury is quite neurophilic and neurotoxic. So nerves are really good at taking it up, and then it's really, really damaging to them, probably because it's so toxic to the mitochondria, and without adequate mitochondrial dysfunction, or without adequate mitochondrial function, then things start going down the tubes. What's really interesting, just to illustrate that by example, is that there's this particular region in the brain called the substantia nigra, and when that gets damaged, then people develop Parkinson's disease. Because it's an important structure in the brain that produces a lot of dopamine. What's really interesting is that when I mentioned earlier in the podcast that some regions of the brain have 2 million mitochondria per neuron, that's the area of the brain I was referring to. But what's really interesting is that the surrounding areas of the brain that aren't directly involved in that important level of dopamine production, they have more standard levels of mitochondria. They don't have 2 million per cell. And interestingly enough, when people do, when researchers do post-mortem analyses, like, in other words, an autopsy or a biopsy of a person with Parkinson's who's passed away, then they find that the mitochondria and the neurons are spared in that surrounding area, which just really speaks to the importance of the nerve cells, the brain cells having enough energy production, which of course is mediated by the mitochondria, to function properly. So when the mercury gets into the brain, it's super toxic to the mitochondria, and then the brain starts going down the tubes, and then one becomes mad as a hatter. And I believe that's the mechanism.
What happens to those? Sorry, Dave, that was your question. Did you have a follow-up?
No, that's good. That's good. That's what I wanted clarified.
It just led me to a question. Before we maybe pan out a little bit, I'm just curious to see what happens, with the mitochondria as we age. Does that density diminish or the turnover diminish, or what happens? Because you think aging is slowing down and less energy.
Well, there's actually a really fantastic book that was written by a naturopathic doctor in Ontario, actually. His name is Lee No, like Know, and he wrote this book called something like Mitochondria and the Future of Medicine, or something to that effect.
Okay.
And it's a really great book, and I mean, it's written for the general public to be able to read it, and understand it really, really easily. But even as a clinician, I found it was really useful to read about it. It's actually a really wonderful synopsis or summary of the importance of mitochondrial function and how it touches on different elements of human health, etc. And in that book, he talks about the evolution of the various theories of aging. And I can't do the whole history of it justice, but basically the punchline, still go out and buy the book. There's more to it than just this punchline. But the punchline is basically, to my understanding, that the mitochondrial theory of aging is the only theory of aging to date that hasn't been disproven. There's other theories like the antioxidant theory of aging and the telomere length theory of aging and like different things like that, and evidently all of those seem very viable up to a certain point, but then they have a certain fatal flaw that, for example, shows that creatures that have the highest antioxidant capacity in their body, they don't have longer lifespans, for example, than creatures that have less concentration, and that's influenced by a lot of things like their metabolic rate, etc. However, the mitochondrial theory of aging evidently has not yet been disproven, which doesn't mean it's not going to be, but the fact that it's held up to date suggests, well, it's the prevailing theory of why we age. Because indeed, over the course of time, our mitochondrial density in our cells does go down. So there's a really big difference between how many mitochondria you have per cell in each cell when you're, say, 20 versus when you're 85. And that's in part because if our mitochondria aren't preserved over time, because of course we encounter stress, not just mental emotional stress, but environmental stressors, toxins, things like that, then our mitochondria over the course of time can get damaged. And they do have repair mechanisms in place, but they're not inexhaustible mechanisms. Our mitochondrial density does go down. So it really speaks to the importance of trying to preserve our mitochondria. And then also, it does bring up questions about the benefit of different agents or different practices that can stimulate mitochondrial biogenesis, which is the method by which our cells can actually make more mitochondria. So that could be something worth considering if one, notices that they're getting a little bit further away from that tender age of 20 or so, and we're moving in an upwards direction, not a backwards direction.
Okay, related to that then, Bryan, I was going to ask you, so you gave me a perfect sort of a segue there. Can you increase the density of mitochondria by increasing the sort of demand? For example, the easiest thing that comes to mind is like exercise. So can you stimulate a demand for the cell to make more mitochondria in that cell?
It seems to be the case. Looking at the literature to the extent that I have so far, and can't say that I've definitely found every study under the sun, but having looked quite a bit in that 60 to 70 hour window of time, what I've been able to find is that there are several animal studies, like rat studies, looking at the impact of mitochondrial of different exercise practices, but also certain dietary practices, and how that can affect mitochondrial biogenesis. And it does seem that more like that high intensity interval training or HIIT training kind of thing, like that more explosive kind of exercise, does seem to translate into increased mitochondrial density. So that's interesting and exciting. And some folks certainly take that information and say, everyone should be doing this, and this will, definitely increase everybody's mitochondrial density. And it might be true, but when we look at what evidence is out there, all that we have, to my understanding at least, are these relatively short-term studies. Yes, they have done studies looking at humans doing high-intensity interval training. I don't know that they've necessarily done, pre and post biopsies of their tissues and things like that. They might have looked at different markers, but no one, to my understanding, has done any super long-term studies saying that, oh, I'm doing, HIIT training or interval training for even 3 months. Let's see if I'm still getting those benefits to my mitochondrial biogenesis. Because it seems like our bodies as humans, like for better or for worse, we adapt, and that's kind of a good thing in many respects, but then it's also kind of a bad thing because it seems like we have to keep our cells on their toes. So whether you can get away with like, oh yeah, I'll just do high intensity interval training and that'll take care of all my mitochondrial biogenesis needs, maybe, but maybe you need to switch it up. Maybe you need to do some, cryotherapy or some sauna therapy, or you need to switch up the type of interval training you're doing, or maybe you need to stop the intervals for a bit, do some long distance or endurance training. And these are all questions that I don't think anybody has a definitive answer to, because I don't believe there are any studies that have looked at this, but it's definitely something that I think about when my patients ask me that very same question.
Another question I wrote down is the energy that a mitochondria makes, is it localized only to that cell? Like, is it super loyal to that cell, or can you make energy somewhere and it be sent somewhere else?
That is a fantastic question, Dr. Miller. My understanding of it is that
the Krebs cycle is just completely like rolling around in my brain.
It's that sweet irony of like having learned the Krebs cycle and glycolysis and electron transport chains so many times and thinking like, I'm going to memorize this and never use it again. And everything comes back full circle. And it's like, oh my goodness. Yeah. I need to apologize to my undergrad biochemistry professor, I think. It was valuable after all. With ATP, to my understanding, it does stay very localized in the cell because as a point of interest, and as a point of interest to me in particular, because a very large part of my practice is treating patients with what would be described as complex chronic illness. So patients who are suffering from, just really debilitating symptoms. They oftentimes have labels like chronic fatigue syndrome, fibromyalgia, environmental illness, things like that, or just really, chronic symptoms with various body systems that they've been to see multiple clinicians of various stripes, and like they wind up in my practice. And so the reason that I'm so fascinated by that is because I'm fascinated by treating those patients because it's very challenging, but also very rewarding when we help them to get better. But the reason that I bring it back to what you were saying there, Dave, is because when it comes to ATP, if ATP gets outside of the cell, it actually acts as a signaling molecule that there's danger afoot. There's this really brilliant PhD named, have you guys heard of Robert Navio before, the cell danger response?
No.
It's super fascinating. And basically this Dr. Navio, maybe 10 years ago or so, he put together this fantastic review paper piecing together all this research that had been done over the previous 40 years or something like that, including his own research in there. And he put together this theorem that's called the cell danger response. And basically, when a cell is in dire straits, when it's been being attacked by a virus, when it's being attacked by mercury or some other kind of like a mycotoxin from mold, something like that, it goes into lockdown mode and basically says, I need to kind of sequester this threat. I need to shut down mitochondrial function. I need to shut down methylation function. I need to start breaking things down because I don't want that virus to hijack the cell machinery. I want to go into lockdown mode, so we're just going to do some good old apoptosis and just break this cell down because it's a lost cause. But the reason it's called the cell danger response, in part, is because of that localized response, but also because the cell will start hemorrhaging ATP, so that's cellular energy. And as a point of interest, according to Dr. Navio's work, every cell in the body has ATP receptors on the outside of it. So if ATP binds to the outside of a cell, then it gets this message saying like, something is rotten in the state of Denmark. We need to go into lockdown mode too. And if it's just like a run-of-the-mill virus, or like, it's like, oh, darn it, somebody broke a mercury thermometer beside me and I'm getting whooped with some mercury, it's not really going to have a big impact or a lasting impact unless there's some kind of a chronic component to it. So that virus is not going away. The immune system's not kicking it to the curb, or the body is not able to methylate properly to get rid of those heavy metals, or there's an ongoing exposure, or there's too much stress and it's interfering with the body's ability to clear that stressor. Well, in that case, then the body can stay in that lockdown mode. And that's one of the prevailing theories, to my understanding, of why people can get like chronic fatigue syndrome and things to that effect, where they're just so debilitated. It's like, why am I so tired? Why am I so brain foggy? Why do I have zero stamina? Why do I have to lie in bed for 2 days after I just make a trip out to the mailbox to get my mail because I'm so depleted? Well, the cells are in this lockdown mode. So in the spirit of not making a long-winded answer even longer, I believe that ATP getting outside of the cell doesn't happen, because otherwise it would signal that cell danger response and things would not go well in the rest of the body.
Yeah, and I think it's a fairly short-lived molecule, right? Because if it's got that high energy potential, that means it's probably fairly reactive.
Probably, yeah, it is.
Yeah, and I think that's why you could make so much of it. Like you were talking about the mass of ATP that you can make in a day. Mm-hmm. I think it's like it's related to how fast it's made and quickly spent. Like the currency is spent. A transition, so we're going to sort of transition, I think, into more how this manifests into, the listeners that are listening going, okay, maybe I have some mitochondrial dysfunction. One of the transition questions, like a specific one that I thought I'd ask is, because Kara and I have talked with Dr. Justin Gallant and really we got smartened up by him in a really, really thorough way about iron. And so iron carrying oxygen, and now that we assess iron properly, it's very, very common, I find, that tired people have low iron. What's your thinking process when you see someone who may have low iron, but they may have some mitochondrial dysfunction going on too? What's your sort of signs and symptoms that are leading you one way versus the other?
So, I mean, the symptom picture might look exactly the same, because without adequate iron, then you're not going to get adequate tissue perfusion with oxygen. And oxygen is a very, very important component of cellular energy production. It's really what differentiates between whether a person's going to be making lots of energy from the food nutrients they're consuming, or they're going to make a very, very small amount. Like you literally would make 18 times more ATP if oxygen's in the equation. So yeah, the symptoms could be identical. I guess what it comes down to is that a lot of patients, in my experience at least, don't have low iron. Like they come in and they've been they've gone through all the virtually every standard blood test, any second tier or third tier blood tests. They've had scans, here, there, and everywhere, and yet they're still having issues. And so that being said, Dr. Gallant is going to be speaking at our annual Nova Scotia conference. I'm inspired by one of our members said, hey, we want him to speak at our conference because, he's a smart guy on that naturopathic podcast. And so anyway, get schooled on iron soon by the Iron Man. So I mean, there might be some element of a panel there that I'm missing. It's like, oh, good, just get the iron on track, and mitochondria will follow suit. But yeah, that there could be identical symptoms, because the way I describe it to patients is that the mitochondria need so many different things to work properly, like certain vitamins, like particularly B vitamins, certain minerals, amino acids, and antioxidants, and oxygen. And so I describe it as it's kind of like baking a cake. If you need 25 ingredients in your cake and you're missing, baking powder or something, then the whole thing's just not going to really work. So same is true of oxygen.
And it's tough. You have a harder job than Justin, right? Because Justin can just poke a vein, take some blood, and look at iron, right? Like we can do iron panels and ferritin, but you can't like do muscle biopsies and like add up the number of mitochondria or the function of the mitochondria with your patients. So the assessment becomes a little bit, it's more clinical, right? It's more based on your experience of seeing the patterns and the signs and symptoms.
And what are those signs and symptoms then, Bryan? That's a good lead into like what someone may be able to look at in their own signs and symptoms or things that they don't feel are up to snuff.
Yeah, so what I would describe as being the direct symptoms of mitochondrial dysfunction would be anything at all that's related to fatigue. So if a person says, I feel more tired than I should, or I don't have the stamina or endurance that I should, when I exert myself, I don't recover as quickly. And so that could certainly apply to like my typical patient who's having a lot of chronic health issues, but it could also apply to someone who's like, I'm feeling okay, but I'm maybe at like 70 or 80% optimal energy capacity. And so they are quite possibly dealing with some mitochondrial dysfunction as well, or underfunctioning of their mitochondria. The other big clue, aside from fatigue signs and the symptoms of revolving around fatigue, would be brain fog as well. And to my understanding, having on this mitochondria research journey that I've been on, it was very interesting to find a couple of papers looking at brain fog. And for all intents and purposes, the conclusions of these papers, to my understanding, is that brain fog is basically equivalent to saying my brain is tired. And if my brain is tired, then therefore my brain has mitochondrial dysfunction, because that's where the energy comes from. So brain fog and fatigue in various manifestations would be the most direct symptoms. Interestingly enough, there can be some indirect symptoms as well. So sometimes sleep issues, so insomnia can be related to mitochondrial dysfunction. I think there's a very compelling argument to be made to suggest that osteopenia and osteoporosis could be related to mitochondrial dysfunction. Sometimes chronically tight muscles can be related to mitochondrial dysfunction. And there's other issues that come up as well. Anything where there's like dry skin or any condition where you think, I wonder if those cell membranes, those good fats are getting oxidized. Those would all be conditions where maybe the mitochondrial dysfunction is a component of that. And I say that in part because it makes sense based on the literature. There is some supporting evidence, but also that I've seen some of those symptoms, maybe not osteoporosis directly, because that's a much more chronic, very slow moving condition, but virtually everything else I mentioned, I've seen those symptoms improve or go away in some patients when they're optimally supporting their mitochondria. Not every insomniac out there needs mitochondrial support, but I have seen it improve. And so that tells me that clinically there's a basis for looking into it, at least in those conditions.
It's really showing up in those tissues that require a lot of money or a lot of energy to run them. So brain, muscle, heart. And I actually heard you speak on another podcast, and I thought I'd like to pass this because this tip was like, oh, I never thought of that. But you had said something about how it takes more energy for muscle to be relaxed than to be tight.
Right. Yeah. And I remember seeing you post about that on one of the clinician groups that were both.
Yeah, I was like, really?
Yeah. And so I saw that statement, and anyway, so it's a little bit of a semantics, because it does take more energy, but not that it's more ATP going into relaxing a muscle, but rather it takes additional ATP to relax a muscle. So more, I guess, is a little bit of a semantics, but when a muscle is relaxing, then so contracting a muscle, like I'm curling my 10-pound weight in my basement, and so that's going to take a certain amount of ATP to contract that muscle, and then when I'm letting it back down again, then my muscle's relaxing. Well, my tricep would be contracting at the same time, I suppose, but anyway, so that bicep muscle is relaxing, and for that relaxation to happen, it takes way less energy, but it does take energy for those actin and myosin heads to release from each other as those muscle units are relaxing. So, which is why when a person dies, their body goes into a state of rigor mortis because the body needs ATP to relax those muscles. And so initially there's that tightening because the body's pool of ATP is just kind of going down. And then
I have another example. So you just put together some kind of geeky science to something my husband said the other day. Because the other day I came home from work and I funnily enough said to him, let's go run that hill. So we ran that hill. We have a hill right beside our house. So we ran it 4 times. So proud of myself. But I said to him, I'm like, I love running down the hill. Like it's actually really relaxing and like feels good on my body. He's like, no. That's the one your muscles are going to be so tired from tomorrow when he's a physio. So I don't know, he knows the eccentric and all of that kind of contractions, but I'm just thinking like, it's not the contraction, it's almost the opposite of that. And I'm wondering if he knew that's why it's going to cost me today. And it did. It really cost me.
Bryan, I want to ask you, you said about osteopenia and how it's kind of got like this slow onset. And it just sort of reminded me of one of the things I like to look at when I'm trying to figure out like what's going on with someone, like trying to do a good assessment. Kara and I go on and on about this, and we're going to keep saying it. A good treatment depends on a good assessment. Like that's all of you good clinicians that we get on here. You all do the same thing. You do a good assessment because then, I mean, you're already setting yourself up with a way more precise angle for the treatment, right? So one of the things I look at is sort of like the slope of onset. So an example of this would be like you were fine for a while in your life and then you had some infection. And after that, it's fairly clear chronologically, quickly, there was like a high slope or something changed fairly quickly. The slope being slow for us. What would you say in general, if you think of your people that have mitochondrial dysfunction, what would you say the slope is like? Is it like something happened and their mitochondria just like went on strike or whatever, emigrated? Or is it like a gradual decline? Because that can be very helpful in assessment, right? Of like, what's the nature of the onset? Was it slow or was it sudden?
Yeah, it's a really good question, and I think that it could be either. I think it just depends on how much stuff is kind of piling up on them. And I think that with mitochondrial dysfunction, the tricky thing with it is that the hallmark symptom of mitochondrial dysfunction is that the body isn't making adequate amounts of energy. And so if the body was already kind of hanging on by a thread because that person was, working 60 hours a week, they had 3 kids, they're volunteering, like they're really, they're getting 6 hours of sleep a night, they're not eating a very good diet, but they're feeling okay because of that amazing buffering capacity that our bodies have. And then suddenly they come into contact with Lyme disease, or they, there's water damage at their work and they get exposed to mold and they get, sick from that. It's like, well, they could go just like tumbling downhill so fast because it was just, the perfect storm, and then their system just shut down. And so in that case, you might look at the history and say like, oh, wow, like, you were feeling fine. You were like on top of the world. And then like, boom, you got hit by a ton of bricks, maybe by a ton of bricks. And in that case, it's like, well, yeah, their mitochondria were probably struggling for quite a while before it got to that point. But then in another case, it might be that, oh, I'm leading like this beautiful, pristine life, and I'm meditating and I'm eating well and taking care of myself. And let's just say I even have good genetics to boot, like a good methylator, all that good stuff. But then they get hit with, so they get, I'll pick on Lyme disease again, like they get bit by a tick, and maybe that tick wasn't just carrying Borrelia burgdorferi, it was carrying some other bacteria as well, and that led to some kind of a viral reactivation in their body because they were, unbeknownst to them, exposed to the monovirus when they were in high school. And so suddenly they're like, wow, I'm taking on like 2 or 3 like super potent infectious entities, and it could just really throw their body right into that cell danger response, into that lockdown mode, and where, yeah, as you touched on earlier, like we don't store ATP. It's like, wow, I'm in cell lockdown mode now. I can't really function, and I can't, for whatever reason, like, I just can't pull myself out of it. So it could be very, very fugacious like that as well. So I think that it's it's really a matter of like, always, and I love what you just said there, like where you guys, it's all about, paraphrasing, but like a good assessment is so key. And that's what I'm always telling my residents and my students that come to, that I'm speaking to or whatnot or teaching. I think it's really, really important to look at that history, because trying to piece it together, like you need to piece the story together, but seeing, does mitochondrial dysfunction fit in here? And if a person's chronically ill, it's like, yes, it definitely does, in my opinion, in my experience. It's really, I guess, a question for your listeners who are not dealing with chronic illness. And I keep going into the chronic illness thing here. So, but it does have applications for folks who are not chronically ill as well. It does have applications for folks who are like, yeah, I'm feeling pretty good, but I'm not at my best. And so there's definitely applications there too.
So once we get to the place where, or you've gotten to the place in your assessment that you can say, yes, the mitochondria are struggling here. Like they're playing a role. We don't know how much, but I think it's playing a role. What is the next step for you as a clinician, if that's what you're suspecting?
So it depends on the case, of course.
For sure.
Because with mitochondrial support, especially in folks who are dealing with more challenging health issues, once you start supporting the mitochondria, we don't get to choose what the body's going to do with that ATP. So of course it's like, oh, let's give you mitochondrial support, and you have lots of energy, and you start feeling like Superman or Superwoman, and you're good to go. Well, the body sometimes has other ideas. Sometimes the body says, oh, good, we have more energy. Let's try to get rid of that mercury that's intoxicating that cell, or let's go start trying to kill off that chronic infection. Well, that could make a person feel a lot worse before they feel better. They might have a detox reaction / Herxheimer reaction / healing crisis, as it's sometimes called. So we have to be really careful with who we start support. We have to be careful when it comes to supporting the mitochondria to make sure we're not going to overwhelm a person's system. But for a person who's generally healthy already, or let's say they were dealing with their chronic gut issues, for example, or they're dealing with their blood sugar dysregulation, and then they're like, great, I'm making really good headway with my naturopathic doctor, whoever I'm working with, and I'm feeling pretty good, but I'm only at like 70% energy, or my brain's just not what it used to be. And I guess I'm, quote unquote, getting old. And it's one of my pet peeves when people under the age of like 95 blame their age. Well, it's like, no.
You hear that, Grandma? You hear Dr. Rade?
It's one of those things where it's like, yeah, I'm just, I guess this is as good as it gets. It's like, no, not at all. Like I have very, very healthy 80-year-olds in my practice and a couple of 90-year-olds, and it's very achievable. For patients or individuals who are already quite healthy, then usually we can jump into a fairly robust mitochondrial support protocol pretty much out of the gate. We don't usually have to hold back, in terms of ramping it in a little bit slower.
Okay. And I mean, as naturopaths, we have a lot of tools in our belt. So what are the tools you're using for those mitochondria?
Well, again, it comes down to, do the mitochondria have all the ingredients they need to function properly? So all those nutrients. So like, do you have all the ingredients to bake the cake? And then is there anything that's standing in the way of them working properly, like the heavy metals or mycotoxins or whatever it happens to be? And so from the toxins or the mitochondrial interfering agents, if you will, that would come down to like looking at exposures and things and maybe doing some testing and that kind of thing. But let's just say for argument's sake that none of that's on the table, or it's just a negligible thing. When it comes to making sure the mitochondria have all the nutrients they need, it's really challenging to determine that ahead of time, because aside from something like iron, for example, which we have good lab tests that can tell us about that, and even other nutrients where we get some insight from, say, like a serum B12 or a serum folate or whatnot, for most of the nutrients that the mitochondria need, we don't have, to my understanding, really reliable, reproducible lab tests to tell us exactly what the tissue levels of a nutrient might be.
Mm-hmm.
Yeah, sure, there's panels out there where you can test B vitamin levels and minerals and amino acids and all of that. But my question is always, well, did they ever look at the level in the blood or the urine, depending on the test, and then do a tissue biopsy of the brain and the muscles and the hepatocytes and the pneumocytes and everything, and see, are the levels in the blood actually correlating with the tissue levels? And I don't believe anybody's done that, and I wouldn't consent to have that study done on me anyways. It would be very invasive. And so where we don't really, in my opinion, we don't really have reliable, reproducible test to tell us about all of those nutrient levels that mitochondria need to function properly, then what I usually recommend doing is working with all of those nutrients simultaneously at robust therapeutic doses and saying, you know what, if you're getting a little more vitamin B3 than you need, you're just going to urinate it out. You're getting a little bit too much alpha lipoic acid. Can't really have too many antioxidants in the grand scheme of things. You have a little too much CoQ10, that's not going to hurt you either. You're going to have a little more taurine than you need. That's okay. It's an important antioxidant or an important amino acid. You can't really overdose on that either. So by working with these things, we thankfully, to my understanding and my knowledge, and certainly in my clinical experience, can't really do any harm with giving patients more of nutrients that they might not really need, because whatever the body doesn't need, it's either going to flush it out or it's going to utilize it for something. If I don't need alpha lipoic acid for my mitochondria, I'm probably going to find a use for it somewhere in my brain or my lungs or something like that. So what I've found in my practice is a couple of formulas that when we combine them, like literally 2 formulas that have all of those ingredients that the mitochondria need, and being in these 2 concise formulas, it thankfully just keeps the pill count and the cost way, way down.
Mm-hmm.
One of my big barriers in practice to really thoroughly treating the mitochondria was that looking at the laundry list of everything the mitochondria need, it's like you would literally need about 25 different supplements, and you'd be taking like 60 pills a day, and it just crazy amounts of things. And so by kind of creating these custom formulas, then it's thankfully allowed patients to be able to access robust doses of all these nutrients without, popping tons and tons of pills a day and dropping, tons of money a month. So that's the approach that I've taken. But you could also, probably use a little bit more of a piecemeal approach. And if you're like, if one was a smarter clinician than me and was like, I can spot a taurine deficiency across the room, or a proline deficiency or whatever, or a molybdenum deficiency, it's like, fantastic. That's great. I'm not that smart. So I just like to use that shotgun approach, and it seems to work really well in my practice.
His name is Paul Anderson.
Oh, there we go. That's he's my biggest mitochondrial mentor, Dave. Like I owe all of my passion for mitochondria to Dr. Anderson. So yeah, very, very good call mentioning him.
Yeah, I was telling Kara, like, Brian's our Canadian, younger, East Coast mini Paul. So you can't get
that is high praise, Dave.
Yeah, exactly.
Yeah. Awesome. And what about so you're adding back things into the system. What about nutrition and movement? Are there things there that are, I think you mentioned a couple studies, but what's
actually,
your
can I tag on to that?
Yeah, tag on.
Okay, I just want to tag on to that. I was going to ask something similar, more just about like, what's the sort of baseline foundation stuff that you'd like people to be at before they go to you for your ability to juggle complex chronic illness? Because when I see those complex chronic illness people, I go, oh man, I got to do another Paul Anderson webinar or listen to Brian, because it's difficult, right? Let's be honest, it is difficult. And so there's like 2 parts to the question. Is like, how do you set people up for the sort of the process that you're going to take them through? Because like you said, it's a bit, you kind of got to do this and see what happens, and do that and see what happens. And that can be, people want things, quick and dirty and fast and reliable and all that. But the other side of that is you can avoid some of that unknowns by making sure people like do some basic foundational stuff.
Yeah. So I think that in general, it's usually an asset to be trying to work with a, hypoallergenic diet, and I would say hypoallergenic tailored to the patient in question. So, whether that's the, sort of a standard, gluten-free, dairy-free, sugar-free extravaganza, or it's more like a paleo type thing, or it's a modified ketogenic thing, like whatever makes sense for the patient's constitution and physiology. Making sure that the patient is having regular bowel movements is pretty important, because constipation is just a surefire way to, slow down the rate at which somebody's going to get better. I also think that if patients have some, coaching or practices ahead of time where they are thinking about, sleep hygiene, thinking about mindfulness, trying to achieve some work-life balance. These are all things that are sometimes much easier said than done. But all of those things I think are really good prognostic factors to predict that there's going to be a better response, like to treatments that we're working with. So all of those types of things would be great. And then also just any symptoms that can get mopped up ahead of time, like where I get a fair number of referrals from other clinicians. It's always fantastic when they come in saying, like I went to go see Dr. So-and-so for my my chronic fatigue issues, my chronic pain issues. And that person really helped, the other doctor really helped to fix, like, my gut's doing great now, my bladder's great now, but I still have these other symptoms. Like, awesome. Now we don't have to do that stuff. We can, we know then that we don't have to go back in time where I'm saying, well, sometimes when we fix, the gut stuff, or, figure out how to get the gut stuff to resolve, then sometimes it helps the pain and fatigue. And it's like, okay, in your case, unfortunately, it didn't really make a difference with those symptoms, but now we know, and we don't have to, quote unquote, waste time trying, these other avenues. We know we can really hone in on the X, Y, or Z that seems to be the more pressing feature that's affecting those, pressing factor that's affecting those symptoms. Okay. So that all of those things would be really helpful if they were already done before they came in through my door. And I would dare to say that half the patients would probably not ever need to come see me then if they did all that stuff, because the basics, or the foundational things, I should say, like, oftentimes make a huge difference already.
Mm-hmm. It's probably the same for any specialty, right? If you do those basic things, they might not need to see the gut guy, or all of your geeky stuff guy, or might not need to see me for hormones, because it's a great point. Like, sometimes those foundations clean up the need for any further fancy, cool stuff.
Yeah, like any drug or supplement is going to work better on a healthy sort of hardware and software, right? Like, it sounds, I mean, I found it humbling, guys, I have to say. Like, I thought when we got out of school, it's like, oh, I'll fix everything with this or that and this intervention and look at me go. But, like, I have to say, the people that come in doing the basics first are the ones that end up doing the best with whatever strategic interventions you can leverage that foundational stuff with.
Speaking fun stuff, I have to switch it to hormones just a little bit, because when you talk about mitochondria and energy, there's a lot of parallels when we're looking at the endocrine system. Whether we're looking at adrenals or thyroid or sex hormones. I'm just wondering if there's an interplay there, or because a lot of the symptoms seem to be similar.
Yeah. So it's a really great question. It's a fascinating topic to me. So I mean, kind of a two-part answer. So one is, what does the scientific literature say? And then the other is, what do we see in practice? Yeah. So what's really interesting is that when you look at, say, the adrenal glands, like, I've heard people describe the adrenal glands as being like the battery packs of the body, for example, or like they're so important for energy, and they are. But when you look at what adrenal gland hormones actually do, like notably cortisol and adrenaline, they ultimately tell the cell to make more energy in different parts of the body in the face of stress. And who makes the energy? It's the mitochondria. The adrenal glands themselves, or the hormones they produce, they don't just magically, alchemy some energy and ATP out of thin air. It's all about talking to the mitochondria. And similarly with the thyroid gland, it's like, oh, the thyroid gland, controls energy, and it controls metabolism. And it's like, yes, it does, but it does it by asking cells in the body to make more through the mitochondria. So I've had, so that's kind of that's the sciencey part of it, or the literature part of it. The clinical part of it is that I've had many patients over the years, many of my own patients, where before I knew more, it's like, wow, if you have low energy, it's like, look at adrenals, look at thyroid, make sure there's no B12 or iron deficiency or whatnot. Obviously look at diet and things like that. But what I found is that I had a number of patients who were doing everything right, and yet they didn't really get much benefit from their adrenal gland support herbs, or their thyroid panels looked great, like even extended panels, or they were on sustained release, T3, like fancy pants, thyroid hormone protocols or whatnot, and some patients feel like $1 million on that, and I had many patients who didn't feel better, or didn't really feel much better. And so with 2020 hindsight, they probably had some mitochondrial dysfunction going on that wasn't being addressed, because just because the thyroid hormones are there, or the adrenal hormones are there, if they're knocking on the door and the mitochondria just can't crank out enough energy for the demands being placed on them, then it's like you can't get blood out of a stone. So in more recent years, I've found that patients who come in saying, I'm tired and I've been on rhodiola and ashwagandha and all these different things, and iodine and selenium and all these things for my thyroid and whatnot, and it's just not really packing much of a punch. And again, sometimes it packs a huge punch, but when it doesn't, then what I found is that many of those patients wind up having signs and symptoms of mitochondrial dysfunction. We start working on that, and then we finally get their energy levels on track. So from the adrenal and thyroid component to things, there's a big mitochondrial link. I could say a little bit about sex hormones, but I can't speak quite as eloquently to that, so I'll just leave it there.
All right.
So it sounds like just one more thing. It sounds like if I could try and sum it up, it sounds like the hormones give like a directive from like management, but in the end, the mitochondria are like the boots on the ground, like the people that still have to do the work, like an overworked employee just can't do anymore. It's burned out. So actually, you're teaching me a lot here, Bryan.
Well, what I've taken from it is like, I mean, as naturopaths, we're like, what's the root cause? What's the root cause? But you can't go back much farther than this is a pretty big root cause. It's just like money, right? Like money is the root cause of a lot of good and bad. And so are mitochondria. It's, would you agree? Would you say that like if you can keep stepping back and asking what the root cause is, and often it might end there?
I think so. Yeah. As you said, you can't really get much further back. And also, as mentioned earlier, all the various toxins or negative things that affect human health, like they have a direct impact on the mitochondria. Like that's in large part how they exert their toxicity. It gets really interesting. I mean, I think you can walk it a step back further, because at the end of the day, if there's too much stress, if there's not enough balance in a person's life, that can have an impact too. And then of course that feeds back into, learned behaviors and patterns and stress coping mechanisms or lack thereof. And so I think that a person could make a pretty reasonable argument to say like, yeah, mitochondria maybe on a physiological level, that's about as root cause as it gets. But then of course you can take it back further with more like mental, emotional, stress management, well-being, and all that stuff too. So, but yeah, physiologically, I think mitochondria is about as deep as it gets, in my mind, anyways.
So, speaking of balance and having good balance in your life, we know you have to get going soon. So, we want to encourage balance in your life. But before you go,
there's no balance when your kids are home and you're trying to school them and work from home. There's no balance.
It's just controlled falling. But
yes.
What I'd like is if, Bryan, you could leave our listeners and me and Kara, because I feel like me and Kara learned a lot here too. If you could leave us with like one sort of important thing that you'd like the listeners to get, if they didn't get anything else from this awesome wisdom that you've brought, what do you want them to take home from our talk today?
Well, I think the main thing I'd like people to take home is that if they are struggling with a health issue and haven't yet found answers to it, those answers probably exist. And if somebody has not looked at your mitochondria yet, ask them about that. But you could also potentially ask them about the myriad other things we talked about that either influence mitochondrial health or might be directly toxic to the mitochondria. So it's really in my practice where I have so many, challenging to treat cases, treatment-resistant cases or whatnot, what I found is that by learning more and more and more and trying to study everything, trying to be like a mini Paul Anderson as much as I can be, it's something that has led me to realize that over the years, all the cases that I originally got stuck on, looking back with hindsight, it's like, oh, wow, there was an answer. I just didn't know it yet. So I think that on the reverse end, from the patient perspective, it's like if you have health challenges, then I think it is a good idea to not give up. I think there's a lot of really viable options and answers out there in many, many cases. So that would be the big take-home message.
Awesome, Bryan. So how do we find you, Doc? How do our listeners find you? And I really encourage them actually to check out the videos you do, because they're really,
yeah, your videos are awesome.
Yeah, even, or naturopaths listening, because they're detailed, but they get across some really cool concepts. So how do our listeners find that?
Sure. Yeah. So they're posted on my Instagram profile, which is dr.bryanrade.nd. And then I also post all the same ones on my clinic website, which is the East Coast Naturopathic Clinic on Facebook. So that's the way to find them.
Fantastic. Thank you so much for joining us. I learned a lot this episode.
I'm so glad. Thanks for having me.
Yeah, that was awesome,
Yeah.
Bryan. Thank you so much. My head trying to put some of the pieces together. So thanks so much for taking the time to teach us. And I know you do a lot of teaching through your videos and everything too. So thanks for that on behalf of everyone who checks them out.
Yeah, and maybe we can have you back for chronic infections, which I think is your other baby. How many hours have you put to that one?
Oh man, I can't count that high. Yeah, I'm not sure, but yeah, anytime I'd be happy to come back and chat again.
Thanks so much. Go enjoy your kitties. Have a great night.
Thanks, you too.
Yeah,
Thank
see you,
you.
Bryan.